Hello dear students, we are discussing about the topic of the building construction. In the earlier two lectures, we have discussed about the many aspects regarding the building construction. That is the type of the structures, the different types of the loads which are acting, that we have also discussed in our previous lectures of the building construction. In today's lecture, we are going to discuss about what are the different components of the building and what are their functions that each component is used for that particular building. The topic which we are discussing in the subject of the elements of civil engineering is the building construction. In continuation to the previous lecture, today we are going to discuss about the different components of the building. The different components of the building are: one is the foundation and the plinth, second is the walls, columns and the beams, next is the floors, that is the basement, ground floor and upper floor, seals, lintels and weather sheds, doors, windows and ventilators, roofs and the slabs, parapet, stairs, lifts and the ramps, and the building finishes. The foundation is the bottommost component of the building, while the parapet is normally at the top of the building. In between them, many different components like the floors, walls, doors, windows, ventilators are there. The plastering work and the whitewashing, they are also considered as the building finishes. So this is a comprehensive list of the components of the buildings. Now, we will see that what is each component means, and each component is provided in the building to serve a specific function. So let us start with the foundation. So what is a foundation first? It is the lowest part of a building or a structure which is in direct contact with the ground, to which the loads are transmitted. You see that the structures are constructed on the land. So that part of the building which is in the contact with the soil and which is at the lowest level is known as the foundation. The one of the basic function which a foundation serves is that it transmits the load coming from the superstructure onto the subsoil below it. All the load of the building is to be transmitted to the soil, and the foundation is doing that function. The main function of a foundation is to transmit the load of the building, of the superstructure, to the soil. So that is the first component, foundation. The second component is the plinth. The portion of the building above the ground up to the top of the floor immediately above the ground is known as the plinth. means this part is above the ground but below the floor. This part is provided in the building for a function of protecting the building from the rainwater or any other moisture. So function of the plinth is it protects the building from rainwater or a damp or a moisture. If you see that if the plinths are not provided, there are the chances of the rainwater coming over the floor. And to avoid that, the plinth means the floor is taken somewhat at the higher level than that of the ground level. And for doing that, a wall is constructed for that purpose, and that is known as a plinth. The next component that we are going to discuss is the walls. Is a major component also, because most of the buildings, when you see the walls. What is a wall? Why it is constructed? The walls are constructed by the use of the building units such as bricks, stones, precast concrete blocks, etc., bonded together with the mortar. Mortar is a mixture of the cement and the sand, or it may be also a mixture of the lime and the sand. Mortar is termed as a wall. So it is constructed normally with the bricks. It may be constructed of the stone, it may be constructed of the precast concrete blocks. This type of the masonry construction is known as a wall. Now the function of the wall is basically to provide a partition. The walls are provided to enclose or to divide the floor space into rooms. By the means of constructing the walls, we are creating the rooms. So the function which a wall serves is the walls are provided to enclose or divide the floor space into rooms as per requirement, and also provide privacy, security, and protection against the sun and the rain. These walls provide, first is the separation, partition, privacy, security. It also protects from the rain and the sun. From the earlier discussion, we know that the walls also carry the load in the case of the load-bearing structures. So wall has to carry out a function of transmitting the load of the slab and beam to the foundation. So one of the another function which a wall carries is the transmission of the load also. So wall has a multi-functions to provide as a component into the building. The another component is the column. The column is an isolated, vertical, load-bearing member of small section of the concrete or stone or brick masonry. So this is a vertical member. The function of this column is to transmit the load vertically. It may be of a reinforced cement concrete, or it may be of the steel, it may be a wooden column also. It transmits the load coming from the beams on the subsoil below it. The function of the column is to transmit the load vertically. That is the main function for which the columns are being constructed. The next component is the sill. Whenever you see a window, so whatever the bottom part of the window you see, it is known as the sill. So sill, it supports window frame at the bottom. So when you provide a frame of the window in the wall, there needs a bottom support, and that is known as a sill. The function of this, it supports the window frame at the bottom. The next component is the door. A door naturally is provided for the entry into the building. It is also known as openings of the building. A door is a framework of wood, steel, glass, aluminum, or a combination of all the above materials secured in an opening left in a wall for the purpose of providing access to the users of the structure. It is for the access of the building, it is for the entry into the building. It may be constructed with the different materials. The common material for the construction of the door is the wood. Now, the function of the door is, a door provides access into the room, offers privacy of the sight and the sound. So it also provides the privacy also of the persons who are there in the room. So door is basically an opening. The basic function which it provides is the access into the building. It also provides the privacy. The next component is the window. For the proper ventilation, for the proper air circulation, and for the proper lighting into the building, there should be a sufficient provisions of the opening should be there, and window is a such opening that is provided in the building for the purpose of ventilation. A window is a framework of the wood, steel, glass, aluminum, or a combination of all the materials secured in an opening left in a wall for the purpose of providing light and ventilation in a structure. The basic function which a window is carrying out, so window is an opening made in the walls for providing light and the ventilation. Normally, the window area provided should be around minimum 10% of the floor area for the proper ventilation, so that the proper air circulation and the necessary light in the building is maintained. So, window similar to the door is constructed of the wood, steel, glass, aluminum, or a combination of the above material. The common material which is used for the window is the wood and the glass. Then next component of the building is the ventilator. Ventilator is like a window, but the difference lies here is in the scale or the size. A ventilator is a small window secured in an opening left in the wall. A ventilator is a small window secured in an opening which is left in the wall for the purpose of providing ventilation in a room. So necessary ventilation is to be provided for the purpose of the light and the air. So it is like a window itself, but with the size is small, therefore it is known as a ventilator. Ventilator may be provided in the combination of the door, above the door or above the window. You can have a combination of the ventilator and window and the ventilator and door also. The function which a ventilator is providing, a ventilator is a small opening made in the wall, provided at lintel level for the removal of the exhaust air or the foul gases. Normally, the ventilators are provided at the lintel level. So this is also a very important component considering the point of the view of the ventilation. The next component is the roof or the slab. As the foundation is the bottommost part of the structure, roof is the topmost part of the structure. Normally nowadays, as a roof, we are constructing a reinforced cement concrete slab. A roof or a slab is the uppermost part of a building to cover the space below. The function of the roof or the slab is covering the space on the top. There should be a cover is to be provided in the building at the top, and the roof is providing that function. A roof or a slab is the uppermost part of a building to cover the space below. The function which a roof or a slab is providing, a roof or a slab is the uppermost part of a building to cover the space below and protect it from the sun, wind, rain, and the snow. Next is the beam. A structural member which carries the laterals or a transverse forces is termed as a beam. Beam is a component of a structural frame in which the load which is acting on the beam is in the lateral direction or the transverse direction. It is provided below the slab and rested on the walls and on the columns. The beams may be either resting on the columns, beams may be either resting on the wall, and the function of the beam is to transmit the load of the slab over the wall or the column. The beams are the media by which all loads of the slab transferred to vertical supports, that is like the walls or the columns of a building. So one of the function which a beam carries is the transfer of the load of the slab over the column. Normally, the beams are the horizontal members of the structural frame, while the columns are the vertical members of the structural frame, and the slabs are providing for the purpose of the floor. So these three, slab, the beam, and the column, constitutes the structural frame it is also known as the RCC frame, of which a beam is an important component of the frame. It is a horizontal member. It transmits the load of the slab to the column. The another components we will discuss now is the lintel. Whenever you see a door or a window, on the top of a door or window, to support the wall above the door or the window, a small RCC beam is constructed, and that is known as a lintel. A lintel is a horizontal member which is placed across the opening of a door and a window. So that horizontal membrane which is placed on the window or a door and which supports the wall above that window or a door. So the function which a lintel carries, it supports the weight of the wall above the openings of the door and window and ventilator. So whenever there is an opening in the wall, construction of a lintel is necessary so that the load of the wall above that opening is transmitted into the wall through lintel. Next is a stair. Stair is a component which is provided for the accessibility from one floor to the another floor. Whenever you want to climb from one floor to another floor, the component of that building structure which is used is known as a stair. This stair is constructed in a series of the steps. You know that there are number of the steps are constructed in a stair. The stair is a series of the steps arranged to connect the different floors of a building. So the basic function which a stair is carrying is for the connection vertically of the different floors of a building. The function which a stair is providing, it is the means of a vertical transportation between the floors. It provides access between various floors. It connects different floors, so accessibility of the different floor is made with the help of the stair. So stair is a very important component of the building. The next component that we are going to discuss is the floor. You see that above at the plinth level, there is a plain surface which is constructed on which the inhabitants of the buildings are carrying their activities. That component is known as a floor. The floor is resting directly on the ground surface is known as ground floor, and it is constructed at the plinth level. The other floors of each story situated above the ground level are known as the upper floors. We know that in the multi-storied building there are number of the floors are available. So the bottommost floor at the ground level is known as the ground floor, and all above the floor are known as the upper floor. The topmost floor of the building is called as a terrace. So on the building at the top, whatever the floor is there, that is known as a terrace. The function which a floor provides, it provides a plane surface and supports the occupants, furniture, fixtures, and the equipments of a building. Necessarily, a floor is providing us a plane surface on which the habitants, occupants, furnitures, all other fixtures, everything can be rest. So that is a structure which is constructed at the plinth level, which is known as a floor. The next component is the weather shed or the chhajas. Now whenever you see a window at the lintel level of the window, on the outside of the wall, a small projected part is constructed which is known as a weather shed or chhaja, which protects the windows from the effect of the rainwater or other wind, etc. Weather shed, it is a projected small slab provided at the lintel level above the chhaja, window, door or the ventilator openings and veranda on the outside and of the external walls. So naturally it is constructed outside of the wall. It is constructed above the opening like windows, doors, ventilators, or it may be constructed at the lintel level in the veranda also. So the function of the weather sheds or chhajas are generally combined with the lintels to protect the doors, windows or ventilators from the sun, rain, wind or the frost. The basic aim of constructing the weather shed is to protect the window from any effects of the nature like the rain or the wind. The last component that we are going to discuss is the parapet. This parapet, it is a low height thin wall which is provided on the external walls above the slab to enclose the open terrace. Now on the terrace is the topmost floor of the building. Above the external wall, a small low height wall about 70 centimeter to 1 meter is constructed so that the persons who are there on the terrace may be protected. So the basic function of the parapet is protective in the nature. So parapet acts as a protective solid balustrade for the users. So function of the parapet is the protections of the different persons who are there on the terrace. So this way we have seen the different components from the foundation, plinth, wall, doors and window, floor, roof and many others. Now let us see these components in detail. Foundations. As we have seen, the foundation is the bottommost part of the structure. So foundations are, one is a shallow foundation and another what we have seen is a deep foundation. Shallow foundations are different types of the foundation. One is a spread footing, second is a strap footing, next is a combined footing, then next is a mat or the raft foundation. Let us see the spread footing. As the name suggests, the load of the vertical member like the wall or the column is transmitted to the soil over a large area by constructing a spread or a something like step which will be of the larger surface area at the bottom, so that the load of the structure is transmitted over relatively larger area. The basic function of this spread footing is to transfer the load over relatively larger area than the size of the components. So there are different types of the footing. One is a single footing for a column. One is a stepped footing for a column. One is a sloped footing trapezoidal for a column. So these are the different types of the column footings. Then another is a wall footing without the step, or a stepped footing for the wall, or the grillage foundation. Grillage foundations are constructed for the steel columns or a wooden columns, so that at the bottom the load is transmitted to the larger area at the bottom. So let us see what a spread footing looks like. On the left side, the sketch you see is a single footing. It is a single footing for the column. The sketch in the middle, what we see, is a stepped footing. Because you see in the sketch, there are different steps are provided in the below the column. Prior the actual bottom base concrete is there in the column. So the load is gradually transmitted at the bottom through the series of the different steps, so that the load is transferred in a gradual manner. The next is a sloped footing. In the sloped footing, there is a trapezoidal way the concrete is casted, and there is this type of the normal footing of the column is a sloped footing. The normal way in which the columns are constructed with the footing is a sloped footing. So there the load is gradually transmitted in this sloped way, or this trapezoidal shape of the footing. Here you see a picture of a RCC footing and the column. At the bottom you are seeing there is a wire mesh is there at the bottom, and this is a reinforcement structure in the reinforcing bars you can see, and these bars are connected with the small bars which is known as the stirrups. So this is a picture of the reinforcement which is provided in the footing and the column. So earlier what sort of the foundation that we have seen were that for the column, but here the picture of the spread footing for the wall. On the left side what you see is a simple footing. In the simple footing there is a base concrete is constructed, and above that there is a wall. On the right side, the picture shows is the stepped footing of the wall. In the stepped footing, you see that there is a base concrete is provided, and above that the walls are constructed. The load of the wall is gradually transmitted to the bottom through the series of the different steps. So that is the peculiarity of this provision. Spread footings are normally constructed for the wall. So normal footing, that of a wall which we have seen in the earlier lectures, is example of that. That is the spread footing for a wall. Here is a picture of a grillage foundation. So grillage foundations are example of the spread footing because the load is being transmitted to the ground over a larger area. Here is an example of the steel grillage foundation. The steel grillage foundation, you see, at the bottom there is the number of the horizontal beams are provided. Over these horizontal beams, there are 3 other beams are provided, and over which the steel column is actually resting. And you can see from this picture that the load of the column is transferred to the ground in a much larger area. That is the basic function of the providing this type of the foundation, which is known as a grillage foundation. These type of the foundations are more common in the construction of the industry, where the steel columns are provided for the construction of the warehouse or a workshop. You see, a combination of the different steel beams at the bottoms are provided. These beams are actually serving the purpose of spreading the load over a larger area. This is an example of a steel grillage foundation. Similar to that, here is a picture of the timber grillage foundation. Timber grillage foundation, in which the number of the small wooden beams are spread over the bottom. Over this horizontal layer of the wooden beams or a timber beams, there are another layer of the wooden beams are provided, and above that a central horizontal wooden member, there is a vertical wooden beam is being supported. Similar to that, what we have seen just earlier, the steel grillage foundation, but the material here is the wood. That is the only difference. The rest of the function is same. Whatever the load which is coming over the wooden column is transmitted to the bottom through the much larger area of this arrangement of the wooden planks is known as a timber grillage foundation. Here is an example of the another type of the footing, which is known as a combined footing. In the earlier footing, what we have seen is the column footing. That columns were isolated into the nature. So they are also known as isolated footing. But when in the layout of a foundation plan of the building, when there are more number of the columns at the near distance, the normal practice of the construction is to combine them at the bottom, and that is known as the combined footing. Here you see on the left side there is a rectangular combined footing. Is a rectangular base concrete slab which is constructed at the bottom. This is basically combining the two columns. The shape here provided is of the rectangular. That's why it is known as the rectangular combined footing. Depending on the different sizes of the columns and the load which may be transmitting, it may be trapezoidal also. the picture of which is shown on the right side. So this is a trapezoidal combined footing in which the two columns are combined at the bottom by a trapezoidal shape of either a beam or whatever it may be, a small thickness, then it may be a slab also. So this type of the combination of the footing is provided at the bottom. Here is an example of the another type of the footing which is known as a strap footing. In this type of the footing, you see the two columns and their footings are combined with a specific type of the beam which is known as a strap beam. The function which a strap beam provides is it horizontally connects the two different isolated columns. So strap beam is basically combining the footing at the bottom. So the function which a strap footing is carrying out is the connecting the two columns at the bottom, and that is known as a strap beam. On the right side, you see the another type of the strap beam, but which is not of the same size, because it is a trapezoidal shape in the nature. So this type of the shape is also constructed as per the necessity. So these are the examples of the strap footing. In the strap footing, the important component you see is the strap beam, which is combining the two different isolated footing. One of the method of the construction of the foundation is to construct a raft slab at the bottom. When the soil is of relatively low bearing capacity, the footing of the columns at the bottom is rested on a complete whole horizontal slab at the bottom, and that is known as a raft slab. Over the entire area of the foundation, the entire area, there is one slab is constructed, and this is known as a raft. Naturally, this construction of the raft will transmit the load of the building over a much larger area than if you provide only isolated footing. There will be relatively very small area will be in the contact with the soil. But when you construct this type of the raft, the area is increasing to the much extent, means entire plan. Normally it is the entire plan area of the building, the raft slab is constructed. Over the raft slab, there are numbers of the horizontal beams are constructed, and there is that way the entire network of this beam, and over at the junction of the beams, at the center the columns are located. So this type of the construction of the raft slab will be transmitting the load of the entire structure at the bottom, and in the relatively soils with the low bearing capacity, it is very much useful, this type of the foundation. So this is an example of the raft foundation. Raft slab is to be constructed, and over and above the raft slab, the columns are constructed. This type of the foundation is known as a raft foundation. Here now we will be discussing about the another component of the building, that is the wall. Here is a picture of an elevation of a brick masonry wall. The different layers of the stretcher and headers are laid of the bricks in this type of this particular this wall. This is a English bond. This type of the bonds are constructed into the construction of the masonry walls. The part of the brick which you see of this size of approximately around 20 to 23 centimeter is known as a stretcher, and that side of the brick which you see of the size of around 10 centimeter by 10 centimeter or so is known as the header. Alternate layers of the stretchers and the headers are to be laid for the construction of this type of the masonry. This is an example or a sketch of a brick masonry wall. This is a picture of a brick masonry wall. This way, here the alternate layers of the stretchers are there in this type of the construction method of the brick masonry wall, and you see that the bricks are joined by a mortar. So mortar is a mixture of the cement and the sand. This is a picture of a stone masonry wall. This type of the stone masonry is constructed, and you can see the joints are filled with the mortar. So this type of the stone masonry are known as the random rubble stone masonry, and this is the picture of that stone masonry wall. The walls may be either constructed with the brick, the stone, or nowadays the another material which is used for the construction of a masonry wall is the precast reinforced concrete blocks. Cement concrete blocks are used for the construction of the stone masonry. These are the pictures of the different finishes of the wall. Here you can see the various different pictures of the how the walls are finished. So this may be either pointed, so finished may be there, or the pointing may not be done. This type of the way the different finishes of the brick masonry looks like. So this is a picture of a brick masonry wall. After the discussion of the wall, the different components that we will see is the doors. As we have discussed earlier, the doors are the openings provided in the wall for the purpose of access into the building. It also maintains the privacy also. There are the common material for the construction of a door is a wood, a steel, aluminum, and the glass. These doors are depending on their type. There are many different types of the doors are available depending on the type of the material you say, or how it is divided into the different parts, how it opens. First is the batten and the ledged door. Second is the battened, ledged, and the braced door. Batten is a small wooden plank. So if different batons are used, and these batons are being connected with the ledge. Then it is known as the baton and the ledged door. The second type of the door is the batoned, ledged and the braced door. Braced is the inclined member of the wooden member of the frame. So if you provide this type of the braces, then the door becomes batoned, ledged and the braced door. Next is the framed and the braced door. Framed and the braced door. Next is the framed and panelled door. Framed and the panelled door. Next is the glazed and the sash door. Glazed and glaze means it with the glass. Glazed and the sash door. Next is a sliding door. You might have seen this type of the sliding door. Then is the flush door. One is the another type of the door is the revolving door. Next is a collapsible steel door. Next is a rolling steel door. And last one is the swing door. Now next is the sizes of the doors. The normal sizes of the door we will now discuss. The external door have a size of 1 into 2 meter to 1.1 into 2 meter. The internal door means the doors of the internal rooms are maybe of the size of 0.9 into 2 meter to 1 into 2 meter, and for the bathroom and the water closet size is 0.7 into 2 meter to 0.8 into 2 meter. These are the normal sizes. The height may be either 2 meter or it may be 2.1 meter also. And the width what we have mentioned here may vary within 10 to 20 centimeter as per the necessity. These are the sizes what we have just discussed are the sizes of the residential doors. But when the same doors are provided for the public building like the school, colleges, hospitals or some other, the size may become 1.2 into 2 meter or 1.2 into 2.1 meter or 1.2 into 2.25 meter depending upon the number of the persons for which a room is planned or the size of the room. Larger the size, normally the size of the door will be required will be also a larger. So these are the different sizes of the door that we have discussed. So far in the today's lecture, we have seen the different components of a building. What we have seen is what is the meaning or the definition of that particular component and for what function this particular component is serving, that we have seen in the today's lecture. And we are now discussing the different components in detail in one by one. It is now today's discussion is over. Thank you all the dear students. Thank you.